Hi, I thought I'd just get a little bit nerdy on you. Now, alcohol and drugs like meth and opioids all affect the neurotransmitters of our brain. Remember in my last video about alcohol, I talked how alcohol affects the neurotransmitters. Well, for example, meth affects dopamine, gives us rush of serotonin, adrenaline, ephedrine. And let me go back a step. When you do biochemistry, you learn that nature and everything, all compounds are all based on the basic bond is a carbon-hydrogen bond. So this is going to be a nerdy video. So when you see like diagrams, and I'm going to show you like that, they actually, it says straight line here, that actually represents a carbon-hydrogen bond, and you'll see here. But they'll actually leave it out and draw all these strange figures like hexagrams and everything. Anyway, what are some neurotransmitters? So when I talk about alcohol and I talk about drugs affecting the neurotransmitters in the brain, what are the neurotransmitters? Well, part of the neurotransmitters are amino acids, for example, glutamate and glycine. The monoamines, and that's dopamine or norepinephrine. I'm sorry, I'll spell that. norepinephrine. So that's where speed and ice target those cells. And then you have your peptides, and your peptides include your somatostatin. I'll spell that. I'm very sorry for my pronunciation. I'm not nerdy enough, obviously. It's spelled somatostatin. Somatostatin. There we are, probably pronounced it better that time. And your opioids. And then you have your purines, which is your ATP, your adenosine triphosphate. So you have, in other words, a lot of different types of neurotransmitters, amino acids, monoamines, peptides, and your purines. Depending on what type of drug it is, depends on what type of transmitter. Of course, opioids, if you're addicted to opioids, are going to affect the opioid transmitters. Now, just out of interest, I thought you would like to have a look. Remember I said one of the neurotransmitters is called monoamines. So dopamine, the formula for dopamine is C8H11NO2. So that's 8 carbons, 11 hydrogens, 1 nitrogen, and 2 oxygens. And this is what I wish I could see. Yeah, there we are. It looks like that's dopamine. Then down the bottom is norepinephrine. I have trouble pronouncing it. Now these is what, when you have speed, the uppers, these are what they target. And norepinephrine has C8H11NO3. So there's one extra oxygen. So it's 8 carbons, 11 hydrogens, 1 nitrogen, and 3 oxygens. And that is the formula. If you can see it, I'm sorry. So these two, I'll just show you again, is, over there, is your monoamines of your neurotransmitters. They're the ones where your methamphetamines target. And this is what meth looks like. Meth is C10 H15 nitrogen. So it's 10 carbons, 15 hydrogens, and 1 nitrogen. Notice how similar it is. Notice how that's why our brain, our neurotransmitters, can readily take synthetic things, and they what I'm saying, regularly take synthetic things and think it's the real thing. Like meth apparently is 100 times more powerful than dopamine. So when you have a shot of speed or something, it's 100 times more powerful than that. Anyway, I did for you just a structure of morphine. Now, morphine, being an opioid, goes into the peptides neurotransmitters. Now, remember I said that a line like that represents a carbon-hydrogen bond. So it'd be carbon-hydrogen up the top of the triangle, carbon-hydrogen there. This is the complex thing of morphine. I will tell you in a minute. That's what it looks like. I couldn't be bothered putting it all in because it's so complicated. But morphine is C17H19NO3. So that's 17 carbons, 19 hydrogens, 1 nitrogen, and 3 oxygens. So it looks like, oh, come on, Jen. Because it's a mirror image to me, I can't see it. So I'm sorry. So that's just being a bit nerdy. So alcohol affects your neurotransmitters and drugs affects your neurotransmitters. And all I've tried to do here is just show you the complex bonding that takes place. Meth very closely, and I'll just show you the meth again, very closely looks like dopamine. And that's why your neurotransmitters, if you can fake a similar structure, your receptors in your brain are willing to take the fake synthetics. Thank you. I've been nerdy enough and probably lost half of you, but I just thought I'd have a bit of fun, waste a bit of time, and draw these up for anyone who's interested. Love yous. Bye.